Okay, now we're ready for problem 22. Now we're back to another graph of a function over here, and we're asked, looks like 4 different parts. So I think we can go down here and work on these. Part A, what are the intercepts? We've talked about those before. Intercepts are where the graph crosses or even touches the x or y axis. So if you look at this, looks like this graph touches the x-axis here, and then also it crosses the y-axis, and then touches again the x-axis. So it intercepts or intersects 3 times. And they want us to write them as ordered pairs. So this first one looks like it's -1, 0. Then this next one, which is actually a y-intercept, looks like it's 0, 1. And this last one looks like it's 1, 0. So 3 intercepts. Domain, we've talked before, interval notation. Now here's something interesting. You notice the domain, we're looking for the smallest value of x to the largest value of x. Once again, this is continuous in between, so everything in between is covered. But you notice at the end here, there's no arrow. That means it just stops. So this graph, in this case, it starts here, it looks like at -3, and then it stops at 3. So for the domain, we're looking for all the possible values of x, or all the values of x of this graph or this function. It's like it starts at -3, and we put a bracket because it includes -3, and it goes until 3, and it's included, so we also put a bracket. So the range now are the y's, the smallest value of y to the largest. How far down what's the smallest value of y? Looks like these 2 points are the same, and looks like the value of y is 0. So the range is going to start at 0 with the bracket. And what's the highest, the largest value of y? Looks like both these points are at 2. Looks like the range goes from 0 to 2, including 0 and 2. So we both have brackets. Now here's a new question. On what interval is the graph increasing? And they say, if it is increasing, write your answer interval. So increasing, the way you check whether a graph is increasing, if you remember back when we used to do graphing like slopes, you could think of a positive slope. But if you don't quite remember that, what you do is you go to the negative x-axis, the far left side of the graph, and you begin to move to the right. And as you move to the right, if the line is going down, that's considered decreasing. It's going down. But if it goes up, as I move to the right, then that's increasing. So if we look at this example, once again, I always start to the far left of the graph, and I begin to move to the right. And as I trace this line, the first part of this graph, since I'm going down, it's decreasing. So what we would say is from x -3 to x -1, the graph is decreasing. But look what happens once I get to -1 for x. As I keep moving to the right, all of a sudden it's going up. So this little piece is increasing. I could say from x equals -1 to x equals 0, the graph increases. But as soon as x gets to 0 and I keep moving to the right, now it's starting to go down again. So now I'm in another part where it's decreasing from x equals 0 to x equals 1. But then once I get to x equals 1, it turns around and starts increasing. So it looks like this graph has 2 intervals where it's decreasing. From -3 to -1 is decreasing, and from 0 to 1 is decreasing. And 2 intervals where it's increasing, from -1 to 0, and from 1 to 3. So the first question is, where is it increasing? Well, it's increasing in this little section here and this longer section here. And what they want is, they want the values of x where that function or graph is increasing. So the first one, and I believe this is always confusing, I'm looking, and they want me to put parentheses, which I have to think about that. So we'll just put parentheses. It starts at -1, and it's increasing until x gets to 0. So that's the first part of the graph where it's increasing, but there's another part that starts at 1 and goes to 3. So there's actually 2 intervals where the graph is increasing. Now this one says, where is it decreasing? Well, there's 2 intervals where it's decreasing. It starts at -3. Once again, these are the values of x. X minus 3 to x minus 1. And then there's also another part that's decreasing, which starts when x is 0 and goes to when x is 1. And then the last question, on which interval, not the last one, next to the last one, on which interval is the graph constant? A constant graph would be a horizontal line. If you have a graph, say something like this, the horizontal line is where it's constant. Because once again, the function or the graph is like the x. So what's happening here? The y is not increasing. The function is staying flat. When you get to here, then the function increases. When you get to here, the function is decreasing. So we go look at our graph. Are there any parts of this where it's flat, where there's just a horizontal line? And there is not. So we would say it's not constant any place. Now here's a tricky question. The last one, is the function odd, neither odd nor even, or even? Now this can be a little tricky. One of the things we can do that I know to do, when you have a even function, this is true. What does that mean? That means if you take a number, a value for x like 1, and then you go figure out what it is for -1, they're going to be the same. What does that mean? Let's go up here and look. So let's go choose a positive value of x. Let's use this right here. This is when x is 3. So here's my function. When x is 3, the function is 2. Write that down. When x is 3, the function equals 2. Now, let's see what happens when we make the x negative. What is the function when x is -3? And it's 2. That is a way to check to see if it's an even function. And what happens is, if you check any point in here, and you do the positive number and then the negative, you will see that the function's the same. So this ends up being an even function. Now just so you know, an odd function, if we had to check it, is this right here. When you put in the negative number, it equals the negative function. So we don't need to check that here, so maybe another problem we'll be able to check it. So once again, just to make sure I didn't mislead you, I'm going to check all these answers, which are written here. And yes, thankfully, I did not make any mistakes. 23. All right, here's another, looks like graph and or function and with some questions. Part A, we're trying to see if there are local maximum and local minimums. So maximum or minimums you could think of like peaks. A maximum is like a peak, like I can see right here. That's going to be a maximum. Minimums are like the valleys, the bottom of the valley. So let's see what they're asking us. Select the correct choice. A, the value of x which has a local maximum is or are. So they're asking us for what's the value of x where this function or this graph has a local maximum. Now a local maximum means, you know, at the edges of this graph, actually these points are higher, but that's not considered a local maximum. Local is where you actually have a peak in your graph. So I say when x is 0, we have what's called a local maximum. The next thing is the local maxima is, now they're asking for what's the actual value of the function at the maximum. Well, that points to maximum. We know the x is 0 and the y is 1. Now for B, they're asking about the minimums, the local minimums. Minimums are like the bottom of the valley or whatever. Looks like I have two minimums. And the first thing they ask is, what are the values of x for the minimums? Well, the first one is at -2, and the second one is at 2. I actually have two minimums. And then here, the last part is they ask for what is the actual value of the function, or what is y at those minimum. You can see here, at this minimum, what's the value of y? The function at 0, and over here it's also 0. So you'd say 0, 0. All right. Looks like we might have one more graph of a function where they ask us different kinds of questions. So this is number, I can't even see it, number 24. And we'll finish this video on this one. For the graph of a function y equals f of x shown to the right, find the absolute maximum and absolute minimum if they exist. Identify any local maximum. So absolute maximum minimum are like the edges of the graph. If the edges of the graph are the highest point, those are called absolute maximum and minimum. But if in the middle of the graph you have like a peak or a valley, those are called local maximum or local minimum. So if I just look at this, before they even ask me the questions, right here would be the absolute maximum. That is the largest, the highest point on the graph. It's on the very edge, but it's the highest one. And down here, this is the lowest point on the graph, and because it's on the edge, that's called an absolute minimum. Now in the middle here, we have both a valley and a peak. So we want to call this valley the relative minimum, because it's like this point is the minimum relative to the graph here. And in this point, since it's like a peak, that's called a relative maximum. And the key word is relative, because that point is a maximum in relation to the graph it's nearby. It's not the absolute maximum. It's not the highest point on the whole graph, but it is the highest point in this region of the graph. So let's see what the questions are. The absolute maximum y equals f of x is f. So I think what they want me to put in is here, what's the value of x? I think it's the value of x is 1, and then they say, so then what is the value of the function at that absolute maximum? And you put in 7. In a way, what they're saying is, to make it a little easier to understand, f of 1 equals 7. The 0.17 is the absolute maximum, right? Absolute minimum is down here. What's the value of x where it occurs? 4. So f of 4, and what's the actual value of the function? Is 1. So in other words, we're saying f of 4 equals 1. 4, 1 is the absolute minimum. Now they're asking about local, I guess this one, local maximum. So is there like a peak? And actually there is right here, and it occurs when x is 3. So f of 3, and what's the value of the function at that peak? It's 3. So f of 3 equals 3. Let me see what this question is. It says the local maximum, type integer, the local maximum are, I think part B must mean if there are 2 local maxima. I mean, you could imagine a graph where you have 2 local maximums. What if you have a graph like this? You would have 2 local maximum. However, we only have 1. So I think part A, if you have 1, you do part A because there's only blanks for one maximum. If you happen to have 2 maximums, you use B because I guess there's slots for 2. So then the next one, they ask us about the minimums. We have 1 local minimum, so I think we do A, and we say it occurs when x is 2 and the actual value of the function is 2. All right, so that's our problem about maximums and minimums. All right, that's good for this video, and we'll keep going on the next video.